Welcome back to the channel, you guys, and if you're new here, I really appreciate you checking out the content. This is going to be a really exciting video for a lot of you because of the fact that we're doing a fresh new build, and I'm going to try to walk you through my process of getting everything set up so that you can actually get out there and start enjoying the flying part. There are so many barriers to entry within the FPV hobby, and there's no way that I could touch on every single one, but I remember when I first got started, I felt extremely overwhelmed, and there was one video in particular that helped me out immensely. It was a rotor-ride video done by Ladrib, where he actually did a full build, got everything set up in Betaflight, as well as his DJI goggles, his controller, and all that stuff like that. That's what I want to try to help you guys out with today, particularly more updated, talk about some of the things that I do specifically to get a quad not only set up that way, but also flying pretty damn well. I'm not going to be spending a ton of time on the build portion of this video. I will be talking about some important things to look out for, maybe some things that you can utilize for more troubleshooting purposes once you get everything put together. I have done a lot of other really good build videos in the past. I will actually link some down in the description below, specifically for the Quadmula Siren F5 split, which I've done a few videos on. Absolutely love this frame, especially the new iteration of it. It's a little bit shorter, a little more durable overall. I love the simplicity of building and working on this frame, and because it is a very simple quad, it's also very lightweight and extremely reasonably durable for how lightweight it is. Because of that, it just flies really good. But the frame doesn't matter. You can use any frame that you want to use for your particular build. You're probably going to want to set it up really similarly, or at least that's how I would recommend you set up most frames that can accommodate this style, which is kind of the split deck style. But it doesn't matter. Again, let's just go ahead and hop into the other components. I'm going to be using the DJI O3 Air Unit because it's my VTX of choice. I love the quality. Range and penetration is just insane. I do have a lot of Caddx Vista quads. I have even a couple of Walksnail quads. It's not much different in terms of how you set up a digital video system across the board. They're all pretty much the same, but this is what I'm going to be using. What really matters is how you mount it to your frame. The Quadmula Siren F5 split mounts it directly to the frame. You want to flip the O3 Air Unit upside down because that's the flat side, and it mounts directly to the frame using some new hardware that you can get when you order the frame. You just say, I'm going to use the O3. They'll include these small screws in here for you to do that. You can probably even find like some sort of a 3D print of some kind that you can actually, put the O3 in and then mount it that way to your frame. And again, it really just depends on how your frame mounts it. Overall, the same idea. Typically, you want your VTX here in the back. You're going to be running your wires that are going to be giving the signals to the O3, to your flight controller, such as something like this, whether it's over the top or under the bottom, however your frame routes, it's up to you. But that's the idea. You've got the camera cable that I like to put on the very bottom underneath the ESC, obviously for the camera up here in the front. For my receiver of choice, I'm going to be using Tracer from Team Black Sheep because that's what I've been using from the very beginning. Thanks to Mr. Steele. I like it because it's a little bit faster than Crossfire. I like it because also the antennas are smaller than Crossfire. I hate the big bulky antennas of Crossfire. I just don't recommend them. And I personally just have not had enough issues with Tracer to warrant me switching to anything else. I've flown in bandos, trees, forests, whatever the hell it is. I've flown in a lot of places with Tracer, and just I've never had enough issues for me to be like, I need to switch to something else. The few times I've had fail-safes, my video system was also completely gone. So it's really hard to blame Tracer in those situations. I like it. If you're going to be flying diversity like I am with Tracer, they do also make diversity ELRS receivers. If you're going to be doing diversity, recommend you have one of your antennas parallel to the frame, such as this, and then you have the other antenna on the other part of the quad in a perpendicular fashion, such as this. The overall goal is you're trying to make sure that no matter what the RF pattern of the quad is in itself, it's going to be consistent with whatever your controller has as well. And that's why diversity and using it such as this is going to be more helpful than if you have like one antenna here on the same field. For the stack, I'm using the new T-Motor Velox stack that just recently came out. This is an F722 flight controller with Bluetooth capabilities, which is pretty rad. This is a BL Heli 32 50 amp ESC. I know, RIP BL Heli 32, it is what it is, but it already has a firmware on here. We can still configure it the way we need to. We can get up and flying, no problem. But I want to say a big thank you to T-Motor for sending me these products, just letting you guys know up front. T-Motor did send me these guys to try out. I'm excited because I always like to see and find products that work really well, that aren't going to break the bank, that I can recommend to people. And I have a pretty good feeling about these ones, so we're going to give them a try. As for motors, we're going with the T-Motor Velox V3 motors. These are 2306 1950 kV motors, which I think is a really great size. I haven't particularly used Velox motors in the past, and I'm a little bit skeptical about two-piece bell motors. I have tried other brands, two-piece bell motors in like bandos and stuff, and it's never a good situation. But I think for open field park flying, you should be just fine. And I've heard nothing but great things about Velox motors. And the best thing about these motors is they're like 15 bucks. That's super cheap when you consider the fact that my normal motors are like 24, some of them are even $30 motors. Pretty expensive. So I think this is going to be a great option for a lot of you guys, especially if you're just getting into it. Well, with that, let's go ahead and get the components put into the quad. Again, I'm not going to go into super detail with the build process, but I will touch on some very important things that I think you should look out for as you're doing your build. Maybe some things you can use for troubleshooting purposes. One of the biggest recommendations I can make to you guys who are just getting into the hobby and you're starting to learn to build is to get yourself a solid solder station. This one is awesome. I've been using it for some time. It's fairly inexpensive. I love the fact that it has a heat gun, which comes in handy throughout the build process, which you'll see later. The soldering iron gets really nice and hot, which is what you want to be able to perform soldering very well. And another good recommendation for you guys is to get yourself some helping hands. It makes soldering very easy when you're soldering onto the flight controller or receivers, things like that. A very important part of any drone build is to get your ESC set up correctly. You want to make sure you have plenty of clearance underneath it. It's not touching the frame in any way, shape, or form. You don't want to cause any shorts. You want to set up your cap situation as best as you can. In this particular case, I'm using a double cap configuration. I love double caps. I love that Quadmula makes a space behind the camera for this. I always flip my ESC 180 degrees like this in pretty much every build, even if it's not Quadmula. I just prefer it that way. Management of motor wires is extremely important, not only to the aesthetic of a drone, but also to provide some level of protection for motor wires in the event of a prop strike. I like to use this heat shrink tubing over my motor wires because it keeps it neat and clean, but also adds enough protection in my experience. I like to use my heat gun that I mentioned earlier in this process. It makes it nice and clean looking. And then another important little tip you can do is use your fingers to kind of mush the actual heat shrink tubing into a more like a clean flat form, and then you go ahead and secure it with some electrical tape or however you want to do it. I don't recommend zip ties. It's kind of tacky looking in my experience. I think electrical tape looks neat and clean, and it's also easy to swap out if you need to. The overall goal is you want your ESC looking super clean. You want to manage the wires really well, as many as you can underneath the ESC is super important for having a nice, clean flying drone. The T-Motor Velox Flight Controller does have these really nifty JST connectors on the bottom side, which make it convenient to do swaps and repairs in the future. Just be cautious. I have broken these on other flight controllers in the past, or they've become disconnected in a crash. You'll just have to reconnect them, but it can be a little bit cumbersome. Always pay close attention to the wiring harnesses you're using. There's two different wiring harnesses that actually shut up with this flight controller. One of them works and the other one doesn't. You want to make sure you don't fry your electronics, so pay close attention to this. I am going to be soldering my tracer receiver to one of the included wiring harnesses that came with the flight controller. This is going to be my ground, which is the black wire. 5 volts is the red wire. The blue wire goes to flight controller RX. Green wire goes to flight controller TX. You can see in this diagram, that's the reason why I'm soldering it up this way. Make sure you look up a soldering diagram for your specific receiver so you get it right. Once you're all done, definitely twist up these wires like this because it makes it a little bit neater, a little bit cleaner. You don't want to have them flopping around, and then secure everything up. One of the most useful tools to anyone in the hobby is a multimeter, I would say, and you can pick them up from Home Depot or Lowe's for pretty cheap. You can do various forms of troubleshooting, like checking for your voltages, your 5 volts or 10 volts, and you can also check for shorts using the diode checker here. It gives an audible tone when you have a short, letting you know that the connection points are shorted together, which is a clear path for electrons to move, which is good sometimes, not good for other times. Check your XT connector inputs, making sure that you do not have the tone. You do not see a short here indicated on the multimeter. You want to see the open just like this. Go around your flight controller and check the grounds to the XT60 connector as well, making sure that you do have your grounds shorted together as they should be. You should hear this tone just like so. But also check your voltage as well. This is input battery voltage. This is ground. Input battery voltage, which is open. You shouldn't hear the tone. Ground, you do hear the tone. Just make sure you do not hear that tone for any of the voltages to ground. So now that we have the quad fully assembled, we have the ESC and flight controller in place. We have the receiver installed here on this JST connector. This is on UART3. We have the O3 installed here, and it is on UART2 on the digital video system out UART on this side. We are going to be shrink wrapping the receiver here shortly, but before we do, we're going to go ahead and power everything up after we've done our checks with our multimeter, and then we're going to proceed with the binding the receiver to the controller. But the moment of truth now, we're going to go and plug in a battery, make sure we get all of our tones and we get all our LEDs to light up. All right, we got all of our startup tones that last At the end, the last two tones there means that the flight controller is talking to the ESC, and that's great. We have our LEDs on the flight controller. We have our LED here on the receiver. And yep, we have our LED light here on the O3. So we know that all of those things are getting power, and that's good. Let's go ahead and turn our controller on. TBS right out of the box is normally ready to bind, but this one has already been bound to a different controller. So we're going to go ahead and press the bind key so that it is in the binding state. You can tell that it's binding or trying to bind because of the flashing light that's going on here. So depending on your controller, this might be a little bit of a different process, but here in the TS16, we're going to go into System, scroll down, or you can use the touchscreen here to connect and get into the TBS Agent Lite Lua. We're going to go to the Tracer Micro TX option here, and we're going to hit bind. Here you can see that it's asking if we want to update the Nano RX. We want to go ahead and hit confirm. You can see that it's trying to update the receiver now. It's going to take some time. It's going to actually download all the information onto the receiver, and then it's going to start the process of actually loading that new firmware on the receiver. This is going to happen if you have a firmware mismatch on your transmitter versus your receiver, and it doesn't matter if it's like a newer version on this and an older version on that. It's going to try to update to the newest version that's on the transmitter. Whatever version is on the transmitter is going to update the receiver to it. So you can see that the RX is loading. Do not interrupt. Binding. And it should be good. Binding OK. We are good to go. Hit back, back, back. You can tell that it's bound because we have our bars right here. Didn't mean to touch the screen. And another way that you can tell that it's bound is you have the green light here instead of the red light. So we are all bound to our controller. Now we can go ahead and put the shrink wrap on the receiver and close everything up and then finish the setup process. Now the receiver is in place. It is shrink wrapped and zip tied down the way that I like it. I like to make sure that my wires are not all floppy. The excess wire that was coming here from the O3 is actually also zip tied down in that little bundle with the receiver there. It is very clean. No floppy additional wires or cables or anything in the build that are creating any additional vibrations. This is super important to having a nice clean build, and I tell people all the time, you know, whenever you're having weird sounds, whenever you're trying to fly your quad, especially on just like defaults in Betaflight, and it flies like crap, it really shouldn't fly like crap right out the gate. It might be because of some mechanical issue that you have depending on your build. You might have some floppy wires. That's why I like to minimize the wires that go between the flight controller and the ESC. I try to put as much underneath as possible. I don't want anything tapping or touching against the flight controller in flight if I can really help it. That's the best way to try to get a really good flying quad. A little pro tip when you're putting the shrink wrap on the receiver is to make sure when you have it nice and hot with the heat gun, you use your fingers to kind of mush the edges, the open edges of the shrink wrap. Creates a little bit of a seal. It prevents some excess debris or moisture getting in there on the receiver and causing any issues. Been doing that for a long time, and it definitely extends the life of the receiver. So a couple of housekeeping things we need to do before we get started with the setup process. Let's go ahead and get the programs we're going to use. First one we'll start with is Betaflight. Type in Betaflight in your search bar. Go to the first thing that likely is going to pop up, which is the Betaflight website. Here at the top you see the download section. We want to get the configurator. This is the actual configurator we're going to use to put the firmware onto the quad. Latest releases here. Currently Betaflight 10.10, which works with Betaflight 4.5 firmware. We need this configurator to be able to put firmware 4.5 onto the quad. So scroll down here to the very bottom to get the version that you need for your computer. I would use Windows 64 EXE right here if I was going to be installing a new Betaflight, but I already got it installed. So just do that process, click there, download, click the EXE folder, and just let it load to your computer like you would any other program that you were downloading. Next, we're going to get BLHeli32, so let's go ahead and open up our browser again. We're going to type in BLHeli_32. I know BLHeli32 is dead, but you can still go to their GitHub and download their latest release for their configurator. Right here under downloads, you see releases, click on that, and 32.10.0.0. I would download this version right here, which says just simply 32.10.0.0. This is the one for Windows systems. Download that, install as you would any other program. Next, we're going to get PID Toolbox, so let's type in PID Toolbox in that search bar. Click on the top one right here, and you can see over here onto the right side it says PID Toolbox is the latest release version. Click on that. And for your Windows is what you would download the 0.65 Windows version. And again, install that as you would any other program. Blackbox Explorer is now in a web version, which is pretty convenient because it's constantly updated that way. So if you want to go to Blackbox Explorer, type in blackbox.betaflight.com and it will take you to the new web version of Blackbox Explorer, and you would open a log file as you would in the past, the very similar way by clicking here, open on log file, and choose your log file. When you're getting into the tuning process, you're going to want to utilize Blackbox to do things like filters. If you do use a TBS receiver such as Tracer or Crossfire, it is very convenient that you can just go into a web browser, very similar to Blackbox Explorer, but just type in TBS Agent M, and you'll see Team Black Sheep's website. You want to go to TBS Agent M here. You want to connect a device such as your transmitter, power on your controller, plug in the USB-C right here, link USB-C device. You see it says TBS Tracer, connect, Tracer Micro TX. Once in the Tracer Micro TX menu, you would go down here to the firmware option. You can see that my current firmware is 6.17. There is a newer version, newer release here that is public, 6.19. There is some beta releases as well that are further up. I'm not going to upgrade this right this second, because when you do, it's going to want to upgrade all your receivers. When you connect, you have to rebind, and it's kind of a pain in the ass. Don't really feel like doing that right this second, so I'm going to go ahead and just keep it here. But if you do want to update, you would just select the option and then click the update right here, and it will just do the process. Make sure you follow the prompts, but you'll get the option to reconnect once it goes into like bootloader mode. But just follow the prompts. Very simple to update the firmware on the TBS micro transmitters, whether it's Tracer or Crossfire, it really doesn't matter. And again, the way that you update the receivers is you would rebind after you've done this upgrade for the firmware on the transmitter. You'd rebind the receiver to the controller again, like I showed you guys already, and then you would then just do the thing. It'd prompt you to update the firmware on the receiver, and then there you go. For updating DJI Goggles or the DJI O3 Air Unit or the Vista Air Unit, whichever one that you happen to be using, or even the OG Air Unit, you're going to want to go and use DJI Assistant 2. You would go and back to your search bar, type in DJI Assistant 2. You can see I've already gone here. You want the Consumer Drone Series is the version you want. It takes you to their download center, and you would download the version right here for Windows. If you're using Windows, obviously the Mac is, if you're using Mac, is an option here as well. I don't think I've updated this in quite a while. Looks like there's probably a newer version that I don't have. This is 2.1.21. I think I'm running probably a little bit earlier version. I do recommend updating to the latest version whenever you're using anything like this that's updating firmware and stuff, in case any changes have been made that are important. For example, there was a while there when the DJI O3 Air Unit first came out, if you ever disconnected the camera and you try to reconnect the camera back to the Air Unit, you would get a calibration error or something like that. I don't remember exactly what I think it was, calibration error in the bottom corner, and there wasn't any way to fix that unless you updated to the latest DJI Assistant 2, and then you would connect. This is how you do this process whenever you're trying to update the O3. You want to power up the quad, and then you connect via USB-C right here on the DJI O3. See that it pops up for the Air Unit. Click on that, and then you would see the firmware update versions. If this is the very first time that you are installing the O3 and you've never ever activated it, you want to do this exact same process. When you first open this window though, you'd get a prompt to activate. You have to activate the DJI O3 Air Unit in order for it to be fully unlocked when you arm your quad, or else you won't get full power out and you'll have problems. So if you are running into that issue when you've installed a DJI O3 and you did not activate, make sure you do this process of getting DJI Assistant 2 Consumer Drone Series, power up the quad using a battery, plug in the USB-C, and then just come over here, open this program and activate it. And then you can see here there are versions of firmware that you can upgrade to. I am upgraded to the most current version, so I'm good to go. For your DJI goggles, whether you're using Goggles 2, Integra, Goggles version 2, whatever, it's pretty much the same process. You want to go ahead and power up your goggles so that they are turned on. You're going to open up DJI Assistant 2, just like how we had for the DJI O3 Air unit. Then you're going to go ahead and plug in your goggles. Should connect similar to when you connected to the Air unit. You see DJI Goggles 2 here, and it's going to load the firmware. You can see that I am currently on 1.07. There is a newer, later version of this. I think this just adds functionality to like other quad that I don't use. Added support for DJI Avata 2. Oh, that's cool. I know you can use these goggles for the Avata 2 now. We'll just go ahead and stick with the current version of software that I'm using right now. Yeah, I think these were like other quads. Yeah, DJI Air 3. So yeah, I don't need that stuff. But it's the same process you would do whether you were doing the goggles of the O3. You would just upgrade, let everything load. It takes a while to do that. Make sure it's fully powered on during the process of downloading and loading the firmware. Before really getting into Betaflight configuration and setup, I usually like to bind my goggles to my O3 Air unit. And if you have not done that before, it is a very simple process. You go ahead and power up your goggles, and you want to also power up the quad. These goggles are already bound to this particular O3 Air unit, but if you needed to rebind them or bind it for the very first time, it's a very simple process, and it's very similar again to the Integra goggles, Goggles 3 in the future, or even Goggles V2. You're essentially trying to find a bind button. I think it's different for the Goggles V2. It's been a while since I've used those, but the bind button for this is right here in the center. It's very convenient. You press that bind button, and then over here on the quad, there's a little tiny button on the O3 Air unit. On the CADX Vista, there's a really small button on this side as well. And the DJI OG Air unit also has like a small hole similar to this. You press that little hole with something that can get in that hole, and as they're both kind of beeping, they'll eventually connect. You hear some tones, and it's connected. And you want to make sure, again, that you've got firmware versions that are compatible on both the goggles and the O3 Air unit that you happen to be using. This is the most updated version of the Air unit for software, and the version of firmware that I currently have in my goggles right now works fine with the O3 Air unit, so it works. You want to also do that too in case you're for some reason using really old firmware for either the goggles or the O3 Air unit. You might have issues if you're trying to like watch a buddy who's flying and things like that. You may have incompatible versions of firmware. It's really annoying that that is a thing, but the thing that's nice about DJI, like for the O3, they've updated that firmware version. They really haven't touched it in a long time, so you shouldn't be having too many issues with that. But in case you happen to be seeing something similar to that or issues with binding the two, make sure that you have compatible versions of firmware software. And the best way to do that is just make sure you have the most up-to-date for this, most up-to-date for that. So now that we have all the programs we're going to be using for setting up our quad, the first thing I'm actually going to start with is BL-Heli32. I'm going to get in here, I'm going to make my ESC changes that I like to use for my ESC settings and stuff because I don't want to have to deal with it later. We're going to go ahead and open up the BL-Heli32 that we downloaded earlier. Unfortunately, again, BL-Heli32 is no longer supporting itself. It is what it is, meaning you cannot update the firmware that's already on the ESC. So we're going to see what firmware version is on this ESC currently that came from T-Motor. What you want to do is you want to go ahead and plug in your USB-C cable. You'll see the COM port pop up, but you do need to have power supplied to the ESC in order to move forward with any sort of configuration changes. So now that we have power to the quad, we're going to go ahead and click Read Setup. Current firmware version is 32.10. And yeah, we're using 32.9. It's not too bad. It is what it is. We can't change the firmware version, unfortunately. So for my settings, I like to go with ramp up power of 30. I am going to change my minimum max throttle. You don't have to do this. A lot of people don't. I do for whatever reason. I've always done this. I go 1010 on the minimum throttle, and I go 1990 on maximum throttle. We're going to go with 48 kilohertz for my PWM frequency. I don't like using variable PWM frequency personally. I like having a consistent PWM, so I like to use 48 kilohertz. It's a little bit smoother. There was a video that recently came out from Chris Rosser that talked about the benefits of 24 kilohertz, which There definitely is. I just happen to like 48 kilohertz a little bit better because it's a little bit of a cleaner signal for the purposes of tuning. You can actually push a tune a little bit higher. In my experience, I've seen that with 48 kilohertz, so that's why I use it. And I'll show you a couple of changes that I make because I do use 48 kilohertz on the Betaflight side, but I'm going to go ahead and set that to 48 kilohertz. Now, my timing is set to auto. I don't want that, so I'm going to go ahead and bump this up to 23. And demag compensation low. You can turn the beacon volume up a little bit. I do, because I use my motors as a way to find my quad sometimes when it's lost like in grass or something. I'm going to go ahead and write this setup. I have all my ESCs selected here at the bottom, 1, 2, 3, and 4, and it wrote what I changed to all 4 ESCs. If you happen to want to just change one particular ESC, you can select it by hitting the right click here. And now I only have this single ESC selected. So this is ESC number 1. You can hit the right click and switch between the ESCs like this, or you can just left click and you can select all the ESCs. If you want to write something to all, make sure you have all selected before you hit write setup. So now that we're done with our ESC settings, we're going to go ahead and disconnect. And next is going to be Betaflight. So next, let's hop into Betaflight. Let's go ahead and open up our downloaded program. If you notice that mine looks a little bit different than yours, it's because I like using dark theme. You can change that over here on the options side and use enable dark theme on. And I have advanced CLI autocomplete already checked. It's a very easy feature. You'll see that here in a second when we make some changes in the CLI menu. So now we want to go ahead and connect the quad, the USB-C to the flight controller. We should see our COM port open up again, and we're going to connect. So the first thing I'm going to go ahead and do is I'm going to look at the firmware version that this flight controller is currently using, which is 4.4.3. I don't want 4.4.3, I want 4.5, so I want to update firmware. This is very simple nowadays on Betaflight. I really enjoy how far Betaflight has come, even in the short time that I've been flying. But we are not going to be using show release candidates because that's stuff that's still kind of under development. If you want to mingle and try to play with under development stuff, you're more welcome to do that. But you may need to have a different configurator to work with a new iteration of Betaflight. So 10.10, for example, probably doesn't work with 4.6. You probably need 10.11 or something like that. So just be aware if you're running into issues when you're trying to use like a release candidate or something of that nature. You want to have the right configurator to use that firmware on the quad. So it's very simple here. We're going to enable expert mode. I always have that turned on, and we're going to hit auto detect. We see the T-Motor Velox F7 is selected there, and then here is the latest version of the firmware for Betaflight is 4.5.0 here that just came out in April, and we're going to use that one. There are some options here that you can actually select ahead of time, and I do not use GPS, and I do not use Acro Trainer on this particular quad. I'm not going to have it. I have LED stripped, OSD, SD, and HD. Pin IO and VTX enabled still. I use radio protocol Crossfire. If you happen to be using ELRS, you would also select Crossfire here, but if you're using something different like the DJI controller, you're going to want to maybe select S-Bus here. If you're using Ghost, for example, here's Ghost, but we're going to go ahead and stick with Crossfire for now because that's what we're using. I don't care about telemetry, and the other one that you want to do is D-Shot motor protocol here. So because of the motors that we're using, because of the ESC that we're using, it can do bidirectional D-Shot. So we want the D-Shot motor protocol to be working on the ESC. So we're going to select that. We're going to load firmware online and success. And then we click flash firmware. I'm not going to create a backup. We're going to ignore the risk. It's erasing the current firmware version and putting the new firmware on there. Firmware is flashed, programming is successful now, and we're going to go ahead and connect. It's going to give us a warning here. It says accelerometer is enabled, but it needs to be calibrated. This is a very simple one to deal with. The quad is nice and flat. You want to just click here and calibrate accelerometer. So now when you reconnect to the flight controller here in Betaflight, you're not going to get that error again. There may be a time when you connect to Betaflight and you see an error for motor protocol. In order to get around that, you're going to want to go to Motors and select something as your motor protocol over here. Again, we already selected D-Shot, so by default D-Shot 600 is selected, and we're good to go for that, so we're not having any issues. While I'm already here in the motors tab, one of the very first things I always do is I switch my motor direction because I fly props out. Everybody should. If you don't, then you should try it. I'm going to go ahead and select bidirectional D-Shot here and click yes. I know I do have a ESC that's capable of bidirectional D-Shot because it's BL Heli 32, so we're good to go. You shouldn't have to change these motor poles if you're flying a 5-inch. You might have to look and see how many motor poles. It's basically the number of magnets you have in the bell. If you're using a much smaller motor, like something like a 1404 or something like that, but we are good with 14 here. We're going to leave that value there the same and etc. The only thing we're going to click here is save and reboot. The next thing I'm going to do is I'm going to go to my ports. So I know for this particular flight controller, it has my MSP for my DJI O3 Air unit on number 2, and my receiver was on serial RX number 3. So you have to have this selected for your MSP protocol depending on the UART that you're using for your digital video system. This is true for if you're using a Caddx Vista, even Walksnail, you have to do the same method of selecting the correct UART with the MSP output. The only other thing with this flight controller is it does have a Bluetooth adapter so that you can actually connect to a SpeedyBee app on your phone out in the field, which is pretty convenient. But in order to do so, you actually have to use the MSP on UART 6 as well for that Bluetooth adapter to work. So if you are running into problems of not being able to use the Bluetooth adapter when you're out in the field using the SpeedyBee app, it might be because you do not have this selected, and then we're going to save and reboot. The next thing we're going to do is we're going to go to the configuration tab. So I'm going to use an 8K PID loop because I'm using an F7 flight controller. If you're using like an F4 flight controller, you may want to use like a 4K PID loop. Depending on the gyro that you're using, it may force you to use a different PID loop frequency, like a BMI 270. I think it's like 3.2K or something, but it'll be that by default, so just use whatever is there. We're going to go ahead and use the 8K kilohertz PID loop frequency here because the ICM gyro on this flight controller can handle 8K PID loop, so that's pretty awesome. I personally do not use the barometer because, again, I don't use GPS or anything on this quad. This is a freestyle quad for me. And I also turn off accelerometer. I know this is kind of weird, but this is something I've always done. I don't need the accelerometer, and I've seen that there have been times when the quad has started up and it wasn't necessarily perfectly flat or whatever, when it first booted and plugged it in and everything like that, and it didn't kind of fly straight. It was like sort of angled or something weird, and I was like, what is that issue? So I had heard from a buddy, hey, just try turning off accelerometer and you'll never run into that problem again, and that's why I do it. I never turn on accelerometer. You don't need it if you're flying particularly in full acro mode. If you happen to be using like angle mode or anything like that, horizon mode, which I highly recommend you don't, then you do need to have the accelerometer turned on in that case. So here you can pick a craft name if you want to. I'm gonna go ahead and call this one Money because it looks fucking sick with the green motors here. Pilot name, obviously, the MurdersFPV there. I also do not have air mode enabled permanently. Personally, I like to have air mode on a switch because there are times when you will get stuck to a wall or a tree because the quad is basically going up against it like that, and air mode will keep it stuck. Instead of having to disarm and rearm to catch, you can actually just disable the air mode on the switch and it will fall and you can keep flying, fly away, and then turn air mode back on. Very convenient to not have air mode on a switch. Another cool thing about air mode on a switch too is if you happen to do like a slide or a grind or something, if you're doing that, you can actually turn air mode off and it will prevent the quad from like bouncing off the object really hard. Kind of feels really similar to like a KISS Ultra quad, which doesn't have that issue with the air mode constantly like making the quad jump whenever it hits something. Turn off air mode. I leave my OSD on. What else do we need? I turn RX loss and set beacons on. So in the event that you happen to lose your control signal and the quad is still plugged in via the battery and it crashes or something like that, if whatever the failsafe has happened, you can actually hear the quad beeping. It'll start doing the beacon noise, which is very, very convenient if you're trying to find the quad. And as I mentioned earlier, I use this option because I like to use my motors as beepers. I have that on a switch as well, so if I'm trying to find my quad out in the field, I just go ahead and flip that switch and my motors make a noise. I don't mess with anything else over here. There's no real need for me to change any of those things for the beeper configuration. I just leave them as is. We're gonna hit save and reboot. A little troubleshooting tip, if you are having an issue with your quad when you go to arm, you try to take off or something like that, and the quad is just flipping out, you know for sure that your motors are spinning in the correct direction based on this diagram here. You verified they're spinning in the correct direction when you test the motors, which we'll do here in a minute, and you know your props are on correctly, and you're stumped, why is my quad flipping out whenever I try to take off? Then here in the configuration tab, the issue could be that the board and sensor alignment is not correct. So if you want to troubleshoot this, you do have to turn your accelerometer back on, so we'll do that real quick, and we're going to reconnect. And you can see here that when the quad moves, it moves in relation to the image here that you see in Betaflight. So when I move the quad down, you see the nose of the quad points down. When I point the nose of the quad up, it points up, and you want to see that it rolls on all the axes correctly. What you might see if this board and sensor alignment was incorrect, let's just change this to 0. Maybe you thought it was 0 for some reason, or somehow got changed to 0. You can see that when I move the front of the quad, that it moves the left side. And when I move the left side, it moves the back, and it's all messed up, right? So if you're having this issue, you're noticing this issue, then you want to make sure that you correctly adjust your board and sensor alignment to coincide with what you're seeing. You can see here the different options that you have for completely, trying different things depending on how your gyro is set. This one was already clockwise 90 degrees, so we know that that's going to be the answer. So again, just double check when you get back in here that the quad is moving in relation to the image the way that you're actually moving the quad, so you know everything's good. You go in here and turn accelerometer back off because I don't like it. Boop. The next thing that I always do is go into the presets tab. Not enough people use these, I think, and it's really important that you get in the habit of doing this just because it just makes life so much easier when it comes to setting up your RC link. For example, I'm using TBS Tracer here, 250 Hertz. So what I'm going to select is the TBS Tracer option, and I'm going to go ahead and click drop down, and we're going to go ahead and put HD Freestyle because I'm using DJI 03 Air Unit in here. You can go a little bit more aggressive with the smoothing, or if you want to get really ultra cinematic, or you can go less aggressive with the smoothing and kind of get that real crisp raw feel, depending on the options that you're going to select here. So if you're going to be doing some freestyle, I recommend either HD Freestyle or Freestyle, totally up to you. You know what, let's go ahead and do Freestyle. And I'm going to pick that and save and reboot. So that set up my settings over here under the PID tuning tab. A lot of these things that are changed because of what we just selected, such as jitter reduction, averaging, all that stuff is changed because we selected that preset. We don't have to mess with it, which is nice. We're not having to tune that out. The other one that I like to do in terms of presets is my OSD for my DJI 03 Air Unit. Here, all you have to do is select Map to Display Port and set HD OSD. I like using the HD OSD for Goggles 2. The one that I'm going to want to select here is dependent on the UART that you're using. If you recall earlier, my MSP UART that I'm using for the DJI 03 on this particular flight controller was set to 2. So we're going to select that option. Click Pick and save and reboot. We go back in here under the Ports tab, and we can now see that our MSP option for a UART number 2 that we have selected has the correct setting for the display port, VTX MSP plus display port here that we're going to need in order to be able to use the OSD that we want to for the DJI Goggles 2 and the DJI 03 Air Unit. And whatever other settings that needed to be made are already done by using that preset. Under the presets tab, if you happen to be using a different receiver, such as the Crossfire receiver, I have the 50 Hertz Crossfire set up already because I use that for my long range quads. But if you were using for Freestyle, I would use the other version of Crossfire, which I think is 150 Hertz. Type in Crossfire here, yep, 150 Hertz. I would use this version for Crossfire, particularly if it was me for Freestyle. If you happen to be using ELRS, there is the option here for the ELRS 250 Hertz, which is a little bit faster link, a little less range, but faster. If you're using for Freestyle, I recommend this one, but there are other ELRS versions, so Express LRS, you can see them here. So if you're doing super long range, obviously 50 Hertz, 150 Hertz for like that medium range, that really fast racing speed that ELRS is capable of, I would use 500 Hertz. But again, your range is going to be pretty reduced using this guy, so just be cautious with that. I'd recommend 250 for typical freestyle. Now moving on to the PID tuning tab. These settings are going to be based off my personal experience after having been flying for 3 years and really diving deep into the tuning process. I'm not going to get too crazy right now. I'm going to make some changes that I think most quads will benefit from in here for you. We'll get into a much deeper version of the tuning process that I use in a later video, but for now, this is what I highly recommend, and I'll explain why. So for the dynamic dampening, I turned this to 0. If you notice what that did, you had a different version here of your derivative, your D term for Dmax and derivative term, when you had it here at 1. And what that means is depending on the amount of stick travel is going to initiate more D term. I don't like inconsistency of the feeling of that personally. I prefer to have it a very consistent D term all the time. So I turned dynamic dampening all the way to 0 to achieve that. The other thing that I do right out of the gate, and I've built several quads and I've always done this and never had an issue, particularly because my builds are pretty clean. I'm using pretty decent components most of the time. I've built Apexes, Vanny Pros, I've tried Flyfish RCs, I've tried so many different frames, and this has always been true. But I always immediately go to Master Multiplier 1.4. And what that does overall is it just bumps all of your overall gains to be higher, and therefore the quad is going to perform better. I made a video a long time ago that I titled Better Than Defaults, and basically this is all I did was just bump it up to 1.4, and everybody was like, oh my god, it was like prolific, right? So I always start here, and when I get deeper into the tuning process in another video, I'll explain what I do other than this, but for now this is always my starting point personally. Based on my experience and the things that I've noticed with this particular quad, I usually have a little bit higher P gains. 1.1 is perfectly fine. Might have a little bit more I gains here. Again, this sounds arbitrary, but this is just through experience. I know that if I make these slight changes, things are going to fly the way that I like them, pretty much right out of the gate. And then I'll go from here. This is sort of my default settings. I go from here when I start to really get into the tuning process. But this, for now, is what I typically change right out of the gate. Over here under iTerm Relax, I actually set my cutoff to about 20. It will tell you here in the tooltip what this does, and it will recommend for like freestyle responsive freestyle builds 15, for racing 30 to 40. I kind of have more of like I really want to feel the very, very responsiveness of almost like a racing quad, but not quite, which is why I put it at 20, a little bit higher than what they recommend for freestyle. That's just my personal opinion. You can leave it at 15 if you like. It totally is up to you to go ahead and just try and play with. The other things that I like to turn on are thrust linearization. I do this because I use 48 kilohertz. So I'm going to put 25%. Again, this is just through tons of experience with using 48 kilohertz. Recommendations I've seen from people like UAV Tech. I've talked to them about it and what it does and how it benefits. There was a recent video from Chris Rosso that talked about the PWM frequencies and the benefits of 24 kilohertz and why 48 isn't as good. Well, changing this, you get the benefits of a little bit smoother quad, a little bit more efficiency out of 48 kilohertz, but you also don't lose as much of the thrust power that you would if you didn't change it. Whatever, this is basically what I've always done, and it works great, so I recommend trying it. For dynamic idle, I set mine to 30 by default because I know the props and the pitch that I'm going to be using with this particular quad. It will sort of change what value you'll put in here, but I think me personally, 30 is pretty good across the board for most 5-inch quads. If I'm using a much lower pitch, I might lower it a little bit to like 25, but I think 30 is pretty good. What this really does help with is prop wash and low throttle control. I find that having a little bit higher dynamic idle makes those situations feel much more responsive and a lot less prop wash, so that's why I recommend it. I know you probably saw me arbitrarily just change stick response to 1.3. 1.2, 1.25, 1.3 is usually where I go. We'll start with 1.2 since the gains aren't too high right now. And the reason why I like to have a little bit higher stick response, this is what's called feed forward. It's a really nice feature of Betaflight where when you make the initial stick input be based on your feed forward, knowing that the stick is moving that direction, it actually pushes the quad to go in that direction a little bit sooner. So it kind of removes a little bit of the lag. You can actually see this if you're looking at Blackbox Explorer logs. And just based again off experience and having done it a million times, I know that a value of like 1.2, 1.3 is pretty solid for most quads and how I like the feel of it. So after we've changed that, we're gonna go ahead and just make sure, yep, everything looks good. We're gonna click save. Let's get over into the rate profile page. If you happen to use actual rates, that's totally cool. I happen to use Betaflight rates. I always have, and I probably always will. I just prefer Betaflight rates because they're very similar to KISS rates. The current rates that I'm using right now are 1.7 and 0.5 across all axis. So I'm going to change that. And I have 0 expo. So I've got a little bit of a curve here. It's not like super expo-y, which is kind of nice, and it's not a really high rotation rate. I used to fly much higher. I think I started like 1100, and just I've gradually gone down in my rotation rate. And the reason why I've done this is because the slower the velocity of your rotation, the more throttle or the more resolution you have in the sticks when you're going to full deflection, meaning, you know, the more like control you have of the rotation because it's not rotating as fast in terms of stick travel. So I recommend trying some different rates that you like for yourself. People say that rates are completely personal. I don't think that's true at all. You can just pick any rates arbitrarily and train your brain and just fly those for years, and you'll be fine with those. It's really dependent on you. I would recommend, you know, when you're first starting out, maybe try some lower rates, try some higher rates, see what you like for a little bit. It's just one of those things. Rates are something that you're probably going to evolve a little bit, but once you've really nailed something that you like, stick with it because it will definitely build consistency. For filter settings, we're going to go ahead and just kind of look at this window for now. I am not going to make any changes just yet. I do plan on tuning my own filters later in the tuning video. I'll show you guys how I go through that process. Because I'm not super familiar with this particular gyro, I haven't really used a lot of the ICM gyros. I know MPU 6000s and BMI 270s pretty well, where I could probably make these changes and not even have to look at any black box logs to do so. But I'm going to go ahead and leave this here for now because I know this is going to work just fine for the default settings and the settings that I've already changed. This is going to work just fine. The ultimate goal of filtering is you're trying to reduce as much filtering that you have turned on as possible, because the least amount of filtering that you have turned on, the least latent that the actual drone is going to feel. So it's not going to feel very laggy when you have a lot of the filters turned off. If you have a lot of them turned on like we do right now by default, it's going to be a little bit laggy. And if you get really deep down into tuning your filters and get the perfect filter tune, you'll notice that right away. Over here in the receivers tab, the very first thing that I always change, very similar to what I did in the ESC configurator, I changed my minimum and max throttles or stick thresholds to 1010 and 1990. That's just something, again, I've always done. And yeah, the very next thing I'm going to do, we've already bound our controller to our receiver, but we're going to go ahead and test everything. So we're going to go ahead and turn our controller on. And again, you do need to have power applied to the receiver in order to do this. So we're going to go ahead and plug in the battery. We see immediately that the two are talking because everything just changed here on the screen, all the auxes and everything. And we can see here when we move, like the throttle, for example, we're actually moving that throttle, moving the yaw. Make sure that your roll, pitch, and yaw are all moving in accordance with what you're doing. Also verify your aux switches. So my aux 1, aux 2, 3, 4. You will see when you connect your receiver to your controller, when you make these changes, you know, in the sticks, what's being affected. If you notice that something isn't quite right, then you can try changing the channel map dependent on what it is that you're trying to do. But we're going to leave that now because it's working for me. But that's just for your guys' knowledge. So now that we know that our receiver and controller is working, let's go ahead and move into the modes tab. This is where you're going to set up your aux switches to do what you want them to do. A very important one we're going to start with is obviously to arm the quad. So we're going to add range. We have auto selected by default. That means that the next thing that I touch is going to automatically detect that switch. So my aux 2 is my arm switch. All the way in the down position, you can see here this little tick mark kind of moving when I put it all the way down in the down position. This is where I want it to arm. So I'm going to move this over here. So when it's in this area, this little tick mark, which means at the lower position, it's going to arm the quad. Next one we're going to move on to is the beeper. As I mentioned earlier, I like to have my beeper set up to where my motors make the beeper sound for me. So we're going to add range, and I use this switch, aux4, and we're going to have to move it over here. So when I engage that switch, it turns the beepers on for the motors. Next one we're going to is air mode. I mentioned again earlier that I like to have air mode on a switch. We're going to add range. For air mode, I use my switch over here on the left-hand side, and I like to have it to where it's set for the middle and the bottom position are both air mode enabled. So what I'm going to do that is extend out this area here that's highlighted. So when it's in the middle and bottom position, it will be in air mode. All the way up turns air mode off. The next one is flip over on crash. This is turtle mode. It's super important because when you crash, you land upside down. You want to be able to flip back over and continue flying, and this is how you do that. So we're going to add range. This is my turtle mode switch, aux3. And when it's in the down position, that's when I have it enabled, so we're good there. And last but not least, I recommend using a pre-arm for safety reasons. There's been a few times where I've had my quad in my hand, plugged in with the battery, accidentally hit the arm switch, props turned on, and actually cut my fingers up pretty good. So I have been recently just kind of using pre-arm more so. There's a little bit of a downside if you ever find yourself in a situation where you do need to disarm, like you're kind of crashing, you hit something and you need to kind of get out of it, so you try to disarm. You will have to hit the pre-arm first and then rearm in order to rearm the quad, rather than just disarm and rearm like I have in the past, which is kind of saved me in a couple situations, but it is what it is. I think it's safer to use a pre-arm, so we're going to go ahead and add that. I actually use my same switch that I use for my air mode in the same means, so in the middle and bottom positions when I like it to be enabled. So we're going to have it like that, and we are going to save. So, yep, we know it's working. All right, for the next one, we can go ahead and turn off the controller. And I'm going to unplug the quad for just a second. I want to give the DJI O3 Air unit a chance to kind of cool down before we move into the motor section. When you do have your quad plugged in, your DJI Air unit does tend to get a little bit hot. So I recommend you let it cool down for a second. Don't let it just overheat. So as you remember from earlier, we were already in the motors tab. We already made a couple changes. We changed the prop direction to be props out. We added D-shot and bidirectional D-shot and stuff like that. So those changes are already saved here, but the thing that we do need to change now is the reorder of the motors. This is super important because I installed my ESC backwards. I prefer installing ESCs backwards on pretty much every build that I do. I like having my battery lead kind of come out the front like this because it's protected under the straps. Stays away from the props, does not get chewed up and stuff. I've been doing this for quite a while. I much prefer it, but that means my ESC is flipped because I have my my caps here in the front. So in order to make sure that you're telling the flight controller that the ESC is now flipped, it's important that you do this reorder motor process. So one of the other things that you might run into, like I mentioned earlier, where you might have a situation where your quad's kind of flipping out when you go to arm. If your motors are spinning the right direction, the props are on the right direction, and you've also verified over here under the configuration tab that your board and sensor alignment is correct. One of the last things that might be causing it is the fact that the ESC isn't positioned correctly, and the FC is telling the ESC to spin the wrong motors because you haven't done this process. So we're going to plug in the quad again. You need power to the ESC to be able to do this. We're going to click the reorder motors here, and then I understand the risks, and then start. So we have a motor that's spinning. You just need to click the corresponding motor depending on whatever one is spinning so that you can tell the flight controller which one it is. This one, and this one, and hit save. Again, super important that you do that, or else you're going to have, again, one of those situations where you try to arm the quad and the quad will flip out if you don't do that. Going back into the motors tab, now we're going to verify the motor direction and make sure they're spinning in the right direction according to how we've already told it to. So we're going to use the motor direction little widget here. We're going to understand the risks, and I like to do it individually personally. I don't really like the wizard, so the reason why I like individually is because I like to choose which motor I want to mess with. So I'm going to mess with motor 1. And based on this diagram, we know that it needs to spin counterclockwise. So when you hit this button, is it spinning counterclockwise? Yes. Number 2 needs to spin clockwise. So it's not. Let's go ahead and play with either normal or reverse to see which one will change it. The other one. There we go. All right, now it's spinning clockwise. Motor 3, spinning the wrong direction. So hey, let's reverse that. All right, now we're spinning clockwise as well. Motor 4 needs to be spinning counterclockwise. And we are. All right. Finally, we're going to go ahead and just test all the motors again real quick. You can enable motor testing by hitting this. I understand the risks. Make sure you do not have props on when you do any of this process, of course. Spin up the motors master. Okay, sounds pretty good. When you make changes in the master, you should see the motors changing. And we're just going to verify that the motors are still spinning in the right direction. All right. Turn those off and stop motors. Now we can go ahead and unplug the quad, so we are done with it being plugged in. So now we should, when we go ahead and put the props on, we actually go to arm the quad and do a test hover in just a minute. We should know now that the quad is going to fly correctly now that we've made sure that everything is set up correctly with the ESC positioning, the FC positioning, props are going to be on correctly, the motors are spinning correctly, and we should be good to go. Lastly, we're going to get in here and do OSD. So for the OSD, this is completely dependent on how you want to set yours up. We earlier made the changes with the preset for the DJI O3 Air Unit to use HD, so we already have HD format selected. So what I'm going to do is I have my particular OSD settings that I like. I'm just going to copy and paste these. This is a CLI dump that I had from a previous quad. In order to do this, we're going to go into the CLI tab. We're just going to paste this, hit enter, and save. And that should save all my OSD settings that I like. And I'll show you what I put up here. So my OSD is pretty minimalistic. I have the craft name here. I've got my average battery cell voltage right down here in the left bottom corner. I have the disarm warning letting me know that the quad is disarmed in the center. I have my RSSI value. I mentioned that earlier that I like to turn that on, put it on aux 8. I don't know if I even need to do that. I probably don't, but it is whatever. It's what I do. But I have it right here on the bottom left corner as well. And then all my warnings are right in the center as they normally are by default. So go ahead and set up however you like to do yours. I know some people like to use like current, draw, and all that stuff. I'm very minimalistic in what I like to have. The DJI default OSD already kind of has the overall voltage for the battery over here in this corner by default, as well as the goggles connection. So that stuff's already here in the bottom right corner. And hit save. And that's pretty much it, you guys, for the setup. It really isn't a lot. It may have seemed like a lot, but of course you're going to have this video to always fall back on and come back and visit. You are going to have the timestamps below if you want to revisit any particular section on how to set the things up that we talked about. And yeah, this quad is going to fly pretty solid with what we've changed here for the PID. I am going to get into a more in-depth tuning guide in a later video that's going to go into the nitty-gritty of how I like to set up my filters to reduce as much filtering as possible, and then try to maximize my gains, my PIDs, make sure that I'm not having any, overshooting situations or underdamped or anything like that. But you'll see what I mean when I get into that video. But with that, I hope you guys learned something from this video. If you did, definitely give it a like so other people can find the video. If you have any other questions, please drop them down in the comments below. Hope you guys really enjoy getting out there and flying. Take it easy and have a good day.